All right, so yesterday we started to talk about um, adding and subtracting rational expressions. And I believe we got through example 6 yesterday, correct? Yes, no, maybe? I'm pretty sure we did. So we're going to start with number 7 today. Okay, so number 7, we have 3 over 5x squared plus 7 over 15x the third. And the first thing that we did was we found what's called that prime factorization of the denominator. So if we take a look at our first denominator here, we have 5x squared. 5 itself is a prime number. But what does x squared really mean? X times x. Okay. Let's take a look at 15x the third. 15 contains what prime factors? What multiplies to give us 15? 3 and 5. And x to the third means x times x times x. So now we want to find what's called that lowest common denominator. And to do that, we want to first take a look at what they have in common. So what do those two prime factorizations have in common? They have a 5 in common, and they have a pair of x's in common. Okay, if we were asked to find the greatest common factor, then we would be done. Okay, but we need to find what's called the lowest common denominator. So even though we're talking about lowest, we actually need more stuff. So we have our common, the stuff that's in common. Now we want to take what is called, I just call it the leftovers. So we don't have anything left over with our first fraction, but we do have some leftovers with our second fraction. We have a 3 that's left over and an x that's left over. So our LCD then is when we take what we have in common and take the leftovers and multiply it all together. So 5 times 3 is 15. And then we have x times x times x, that is x to the third. So that's our lowest common denominator. So we're going to take these two fractions and we are going to rewrite them so that their denominators are both 15x to the third. So let's take a look at this first fraction. Our first fraction has a 5x squared. What do we multiply this 5x squared by so that we have a 15x to the third? We multiply it by a 3x. And 3 times 3x is 9x. The second fraction, its denominator was 15x to the third. We're not changing it at all. So what's this numerator going to be? Just the 7. It stays unchanged. Well, we had 5x squared here. We need to get it to be a 15x to the third. So we have to multiply by 3, so we have the 15, and we just need one additional x to get to the x third. Yes. Yep. Okay, so now that we have common denominators, we can combine into a single fraction. Remember, when we add fractions with common denominators, we just slide that denominator over and we combine the numerators. However, the two numerators are these like terms. They're not like terms. So we just keep them separated as 9x plus 7. That's it. That was easy? It's going to get harder. All right, let's take a look at number 8. We have 11 over 28x minus 7 over, no, sorry, 5 over 7x squared. Okay, 28x, what's the prime factorization of 28x? Okay, it's 4 times 7, right? Is 4 prime? Okay, we want to change that 4 to be 2 times 2 times our 7. We want to go as low as possible because we don't know what's going to be coming up in the future. So we might have a pair of denominators that contain just 1 2 in common, but then this first fraction would have that extra 2. So it just allows for the leftovers if needed. And then we have the x. Prime factorization of 7x squared is 7 times x times x. Okay, so what do they have in common? A 7 and the x, right? All right, what's left over? A 2 and a 2 and an x. So when we multiply all of that together, what do we get? 28x squared. Okay, so I'm going to rewrite my two fractions so that I have that common denominator. Okay, so this first one, its denominator was a 28x. Now it's a 28x squared. So what changed? We multiplied by an x. So we're going to multiply that numerator by an x. So now we have 11x in the numerator. The second one, we had a 7x squared. Now we have a 28x squared. So how did we go from a 7x squared to a 28x squared? We multiplied by 4. And this was 20. You would just want to make sure you subtract everything after your minus. Yep. And this one, it's really not an issue because you just have one term there. We'll get to one today where you have to be a little bit more careful. How was that one? Good? Number 9. 7 over 3x plus 4x over x minus 5. Okay, what do these two denominators have in common? I'm so glad you said the x's, okay? They actually do not have the x's in common. I mean, yes, both denominators you see an x. However, this first one, this 3x, that's 3 times x, right? So 3 is a factor, x is a factor. The second fraction, x minus 5, it's separated with subtraction. So because these are separated with subtraction, the x and the 5 here, those are terms. So the 3 is a factor, the x is a factor. Over here, this x is a term, that negative 5 is a term. However, see how I put parentheses around it? When I put parentheses around it, now it's a factor. So our 3 factors here are 3x and the quantity x minus 5. So do we have any common factors here? No. We only have leftovers. We've got that 3, the x, and the quantity x minus 5. These are all leftovers. Okay, so our common denominator is a 3x times the quantity x minus 5.
You don't like solve it or simplify it?
Nope, you can leave it like that. Okay, so this first fraction, we had a 3 and an x in the denominator. What's new to that denominator? X minus 5. So I'm going to multiply the numerator by the quantity x minus 5. Now when I multiply it, what am I going to do with this 7? Distribute it. Good. So what's our new numerator? Good. Okay, our second one, we had the quantity x minus 5. What's new to this denominator now? The 3x, right? So I'm going to multiply by 3x. And what's 4x times 3x? 12x squared. Good. So we're going to have that common denominator. In our numerators, do we have any like terms? No, we don't have any like terms. So now we just want to write those like, or not like terms, we just want to write all those terms in what we call standard form, that descending order. So what term's going to come first? 12x squared plus 7x minus 35. Very good. Yes?
So why didn't you distribute between x and x minus 5?
Because our goal in the end, it doesn't work with this problem, is that we're going to then try to factor this numerator to see then if we can cancel it with any of the factors in the denominator.
So do we just never factor in the denominator?
We haven't had a,
Or I mean just never distribute the denominator?
you're never going to distribute the denominator, correct?
So why do we use, why do you use parentheses, x minus 5, the setting, but not the.
I mean up here?
Yeah.
I mean if you want, because it's a quantity of x minus 5 and this is just, I mean if you want you can. But we don't have any addition or subtraction between these two values, so we're not really distributing, we're just multiplying them together.
Yeah, so why did you use that for?
All right, let's,
Seems like why didn't you use x minus 5 and 3x?
Why did you use 3x and 7?
okay, so look at the current denominator. It already has the 3x there. Look at the new denominator. What's new in this denominator? The x minus 5. So if I put an x minus 5 in the denominator, I have to put it in the numerator.
Oh, okay. So like, okay.
So yes, you are kind of sort of crisscrossing a little bit.
You did it because you put it into that fraction
Yes.
instead. I know.
Okay. Let's take a look at number 10. X over x squared minus x minus 6 plus 4 over x squared minus 8x plus 15. So we need to factor the denominators here. What's x squared minus x minus 6?
X times x times negative x times.
Well, we want to factor the trinomial into two binomials, meaning what multiplies to give us negative 6 adds to give us negative 1. I heard negative 3, positive 2, so x minus 3x plus 2. What about x squared minus 8x plus 15? Negative 5, negative 3. Okay, what do they have in common? They both have the x minus 3's in common. What's left over? The x plus 2 and the x minus 5. So this right here is your LCD. So that means we're going to rewrite both of these fractions so that their denominator contains these three factors. Okay, so that first fraction, its denominator already has the x minus 3 and the x plus 2. What is new to that denominator? The x minus 5. So that is what we're going to multiply by on top. And we're going to go ahead and distribute. So what is this new numerator? X squared
Times negative 5.
minus 5x. Okay, over here, the second one, we have the x minus 5 and the x minus 3. What's new? The x plus 2. So we're going to multiply its numerator by the x plus 2 and distribute. So we get 4x plus 8. So now we're going to combine them. So we've got that common denominator, x minus 3, x plus 2, x minus 5. So let's combine our like terms in the numerator. What's our first term going to be? X squared minus x plus 8. Can we factor this numerator? Do we have a pair of numbers that multiply to give us 8, add to give us negative 1? No.
So when do we factor the numerator?
If you can factor, factor.
Because like for 9, you could like slide and divide. Do you only factor it like if you could do the times?
Yeah, when you slide divide, I just knew that it doesn't factor to what we need. The ones on your homework have a lot of factoring that will allow you to then simplify. All right, last one, number 11. This is one that somebody asked about earlier with the subtraction. This is the one where we have to pay a little bit closer attention because we are subtracting these two fractions. Nothing changes until the end. We still do our factoring. We still find that common denominator. X squared plus 6x minus 7. How does that factor? So what multiplies to give us -7 adds to give us a 6. Positive 7, -1. Good. X squared plus 2x minus 3.
-3 plus 2.
What was your 3? Positive or
Positive 3, negative.
positive 3, -1. Good. All right, so what do they have in common? They both have the x minus 1. What is left over? The x plus 3 and the x plus 7. Okay, the first one, what's new in the denominator? X plus 3. So we're going to put that in the top and distribute. Two x squared plus 6x. What's new in the second denominator? X plus 7. So again, we're going to distribute 3x plus 21. This is where we have to be careful though, because we are subtracting. So we need to distribute that negative sign. So this 3x becomes negative, and this 21 becomes negative. Okay, so we've got 2x squared minus, there's no other 2x squareds here, so it's just 2x squared. Then we've got our 6x and a -3x, so what is that? Positive 3x. And then we don't have anything on this side, but over here we've now got that -21, right? Because we had to subtract it.